Okay, so in this video, I'm going to go through section 10.3, which is estimating a difference in two population means. And so we're looking at first checking the conditions for inference, and then we'll go through a process of finding a confidence interval and using that to draw a conclusion. So a teacher would like to estimate the difference between in the mean number of grades her students can expect to get in a class compared to another teacher. To do so, the teacher selects a random sample of 15 of their 162 students. So this is the original teacher. And then 15 of the 136 students in the other class, and records their current grade percentage. Although the sample sizes are small, the distribution percentages made for each sample show no signs of skewness or outliers. So what they're doing there is they're telling us that the normal large sample condition is met in that sentence. So remember that large sample means that it's greater than or equal to 30, or it's normal or approximately normal or shows no sign of skewness or outliers. So that means that that is not the correct answer because it has met that condition using that sentence. Then the first condition, remember, is randomness. And so the fact that she selects a random sample tells us that the randomness condition was met. The final one is the 10% condition. So remember, the 10% condition is that the sample must be less than 10% of the population. And so when I'm thinking about this, the population values are the number of students that the teachers have. And then the sample sizes are the ends listed. They're both 15. So if I look at the first sample, 15 divided by 162, and the second sample, 15 divided by 136, both of these numbers must be less than 0.10 in order to meet the condition. So if I divide 15 by 162, that equals 0.09. And so that meets the condition. It's less than 0.10. 15 divided by 136 is 0.11. So that does not meet the condition. So the 10% condition is not met for both samples. So remember that it has to be done for both, for all of these. And so that's why it is not meeting that condition, just because of the other teacher sample. So they need to have selected less students for that to be valid for inference. Remember that the only times when the 10% condition is not applicable has to do with if we're talking about an experiment. So if I take my sample and divide it into two groups and do an experiment, that's when you're not checking the 10% condition. Okay, so then examples 2 and 3, we're going to go through a process given the same situation where we're going to find a 95% confidence interval, and then we're going to interpret the confidence interval. And so that's all of the different contexts that we'll see. So manufacturer of cell phones would like to estimate how much longer the battery lasts on their Model 10 phone than their Model 9 phone. To estimate this difference, they randomly select 40 cell phones of each model. So that's going to be our N1 and our N2. So we've got 40 cell phones from each model from the production line. They subject each phone to a standard battery life test. The 40 Model 10 phones have a mean battery life of 14.1 hours. So X bar for the first set is going to be 14.1 with a standard deviation of 2.3 hours. So S1 sub 1 is 2.3. The 40 Model 9 phones have a mean battery life of 12.5 hours with a standard deviation of 2.5 hours. the conditions of inference have been met. So they're telling us that the process that we completed in the previous example is done. And so we don't need to check them again. What is the correct 95% confidence interval? So remember that we're looking at this infinite degree of freedom to figure out the confidence interval value for T star. Okay, so in our formula, we've got T star. Oops. We're going to get that value from the T table using the infinite degrees of freedom at 95% is 1.960. Remember that we're usually going to round to 2 decimal places for a value like this. So 1.96 is that value for T star. So now we have all of the data that goes into the formula for the confidence interval. So remember that sometimes on these questions, it's just going to have you plug into that formula and not actually do any of the math involved. I'm just going to set up the structure of this equation so that I can just substitute in those numbers for each of the values. Okay, so we need to subtract x sub 1, or sorry, the x bar sub 1 minus x bar sub 2. So that's going to be the 14.1 minus 12.5 plus or minus the value for T star 1.96 times the square root of standard deviation for group 1 squared, so 2.3 squared divided by sample size, which was 40, plus the standard deviation for the second model, so 2.5 divided by that sample size, which was also 40. So what we've got then is this plus or minus equation. So again, because it's a plus or minus, we want to simplify the individual things separately. So what I'm going to do is first do this subtraction piece. So 14.1 minus 12.5 is 1.6 plus or minus. I'm going to leave the 1.96 right now and just calculate out this part under the square root. So if I take the square root of 2.3 squared divided by 40 plus, oops, plus 2.5 squared divided by 40, then that calculation is going to give me, and I'm going to round this to 3 decimal places, 0.0537. Sorry, 4 decimal places, 1. So then what I want to do is calculate 1.96 times that number. So that's going to be 1.6 plus or minus 1.053. And then again, because it's plus or minus, I'm doing 1.6 minus 1.053 to find the lower bound of my interval. And I'm doing 1.6 plus 1.053 to find the upper bound of my interval. And so combining those values, I get 0.547 as the lower bound for the proportion that, or mean, that we're estimating, and then 2.653 to be the upper bound for the mean that I'm identifying. So remember that this is talking about the difference in mean battery life for these two models. So looking at it, if we were drawing any kinds of conclusions, because it was model 10 minus model 9, this is showing us that the model 10 battery should last longer than the model 9, from anywhere from a half hour to 2.5 hours, right? If I'm thinking about what those numbers mean in context. So then remember that the definition of a confidence interval is that we can be 95% confident that this interval estimates something. And so if I look at the difference between these problems, right, they all have the same, between these answer choices, this is all the same. We can be 95% confidence that this answer that we got captures something. So remember that what it's capturing is the true difference in these battery life means. So if I'm looking at this, so it's going to be a true difference, right? So look at that. We've got true difference. So mean battery life for all of the Model 9 cell phones. So we were talking about mean. We were not talking about proportion. We were not talking about samples. We were not talking about a proportion. And so for all of them, that's giving us the population, which is what we're always identifying. So it's a mu value, not the X bars that we used in the equation. So remember, the confidence interval always estimates either the population proportion or the population mean. So the answer for C and D would never be true. B would be true if we were talking about a proportion rather than a mean.